Stop worrying about homework and start learning with confidence. This is Ask Learn. Complete help for every subject. Like, share, subscribe for daily learning videos.
All right, so let's take a look at various reactants and see whether these reactions occur. If we're looking at double displacement reactions, we're going to want to take a look and see whether a product is a precipitate. If there's a precipitate, then the reaction will occur. If it is combustion, we can always assume that it occurs. So in the first case, let's take a look at some sulfuric acid and some nitric acid. And these are both aqueous. So remember, in a double displacement reaction, the two positive substances will switch places. But if you notice in this case, they're both H. So we're going to wind up with the same substances that we started with. And so if we start with the same, if we get the same substances that we started with, we can take a look at the states of matter that they're in, and they're both aqueous. So there is no precipitate, no reaction would occur here. Now, if instead we take a look at chromium-3 nitrate, and lithium hydroxide, and switch those two cations. Now the chromium is going to go with the hydroxide. Now it was chromium-3 to start with on the left, so we're going to wind up with chromium-3 on the right. So we're going to need 3 hydroxides to balance out the charge of the chromium. And then the lithium is going to come over with the nitrate. Lithium's +1, nitrate's -1, so we only need 1 of each. And then we can balance the equation to deal with any of the extra nitrates. So like there's 3 nitrates on the left, there's 1 on the right. So we're going to have to put a 3 in front of the lithium nitrate. That now makes 3 lithiums. So I need to put a 3 here. And then we have 3 hydroxides, and a chromium each. So that balances the equation. But now let's see if we formed a precipitate. Hydroxides are generally insoluble, and chromium is not an exception. So that's a solid. Nitrates are soluble, so that's going to be aqueous. But we formed a solid, so that means this reaction occurs because it's a double displacement reaction. Now in the third case, we have a combustion reaction. And we have liquid pentanol, and we're going to react that with the oxygen. So remember, in a combustion reaction, the products are always carbon dioxide and water. So now we just have to balance it. And this one's going to be a little more difficult to balance. All right, so we normally use the Cho method for combustion reactions. We balance C, then H, then O. And what we sometimes find is we have to go back and rebalance. That's what we're going to have to do here. There's 5 carbons on the left, so we should put 5 carbons on the right. 12 hydrogens on the left. 6 times 2 is 12 hydrogens on the right. There are 1 plus 2 or 3 oxygens on the left. There's 5 times 2, or 10, plus 6, 16 oxygens on the right. Now, the only way I can add more oxygen to the left is adding more O2, because if I add it to the first one, it's going to change everything. But the problem is, if I add more O2s, this 3 continues to be an odd number. 3 will become 5, 7, 9. And I'm never going to get 16. So the way that I have to fix this is I have to multiply everything I've already done by 2. So instead of 5 and 6, I'm going to have instead 10 and 12. Instead of the 1 over here where I did nothing, I'm going to multiply that by 2, and I'm going to get 2. Now, why did I just do that? Let's reevaluate our oxygens. I have 1, 2 plus 2, or 4, on the left, and I have 10 times 2, or 20, plus 12, or 32, on the right. Now, I need to get the left side to 32. I already have 2 in this C5H12O, so I need 30 more, in which case I'm going to need 15 oxygens. 15 times 2 is 30 to get 32 on both sides. And this is now a balanced chemical equation. Combustions, you can assume, take place. If the double displacement, we had to check the rules. And finally, if we have some aqueous strontium sulfide, let me just move this over a little. Aqueous strontium sulfide, and we have some aqueous copper 2 sulfate. This is double displacement, so we're going to take the 2 cations and switch their places. So the Cu is going to come over with the S, and the strontium is going to go over with the sulfate. Now, I didn't need to change any of the subscripts. Copper is +2 charge, sulfide is -2, so I just need 1 of each. Strontium's +2, sulfate's -2, just needed 1 of each. And this is also balanced. The same number of elements are found on both sides. But let's take a look at the rules. Sulfides are generally insoluble. Copper is not an exception, so that's a solid. Sulfates are generally soluble, but strontium is an exception. That makes it a solid. So we've generated solids on the right-hand side. That means that this reaction has occurred. So remember, in double displacement, if both products are aqueous, no reaction. If you form at least one solid, there's a reaction. And for things like part C, where it's a combustion reaction, you can always assume they occur.